Okay, hi everyone. We're here to talk about SSL Hell and how to get out of that hell using tools like Cert Manager to automate your certificate management. So as promised, I'm going to say a little bit about ourselves. I'm Gal. With me I have Wukjong and Ajam. The three of us work for Thales in our CPL department. It stands for Cloud Protections and Licensing. Previously, we all worked for Gemalto, and a few years ago, Gemalto was acquired by Thales. Both Thales and Gemalto might not be household names, and the reason for that is because we're business-focused products and not consumer-focused. We do mainly business-to-business. That being said, both companies have a rich history of developing digital security solutions. These solutions are used by banks, enterprises, telecom operators, governments, and departments of defenses. The three of us work on a product that's called STA, that stands for SafeNet Trusted Access. It's an identity management solution, and it's deployed both on AWS and on GCP. It's a pretty complex solution. It has many microservices and backend servers, and we have security certificates deployed on all of them. And we have faced issues made on our staging environment that were caused because of misconfigured certificates and expired certificates. We needed to find a better solution on how to manage these certificates. So let's go over our agenda for today. We're first going to look at the problem, what the problem actually is. Then we're going to look at Acme Protocol, at Let's Encrypt and a demo with Let's Encrypt, a Cert Manager and a demo with Cert Manager, issues and limitations that we have, and we're going to have some time for Q&A. So what is the problem or the hell we're talking about? So all of us know that we need to encrypt our data in transit. We need that both for security issues and for compliances. But in order to encrypt our data, we need security certificate or signed certificates, and these certificates have to be renewed. If we forget to renew one of these certificates or we misconfigure them, we might have an outage. And the manual certificate lifecycle management, it really adds a lot of overhead to do it if you do it manually. In 2021, this year, State of the Machine Identity Management did a survey, and in that survey, 40% of the respondents said that they still manage their certificates using spreadsheets. On average, each of these companies had 3 outages that were caused because of expired certificates in the last 3 years. So let's take a look at one of these outages. This year, in April, Epic Games had an outage that was caused because of expired certificate. Instead of hiding this data, they actually published a play-by-play of what happened, and they're using it as a lesson learned example. So let's take a look at the timeline that they published. At 12 p.m., one of their wildcard certificates expired. This wildcard was used in hundreds of their backend servers, and the outage was really widespread. It was in Fortify, Rocket League, their online services, and in their gameplay store. The good thing is that it took operations relatively a quick time, almost 12 minutes, to realize the cause of the outage. They realized that it was the expired ticket. The moment they realized it, they started renewing the ticket and started rolling out the renewed ticket to all their backend servers. By 12:37, they already started the process of rolling out their certificate. At this time, they already had 25 people that were directly involved in the issue, and many more that were observing or handling small fires that erupted because of that outage. By 12:46, they already managed to roll out their expired certificate to all of their servers, but the initial outage exposed a bunch of infrastructure issues they had, and the whole outage ended up in a 5.5-hour outage. Since then, Epic Games has actually been a very loud advocate about automating your certificate management. Epic Games is not the only company that suffered outages because of expired certificates. Other examples are Microsoft Teams, Azure AD, and Google Voice. So let's take a look why it's so complicated to manage your certificates the traditional way. let's say you're a server admin and you want to add a signed certificate to your server. The first step you're going to do is create a CSR, or a certificate signing request. This CSR will include some identifying data, things like your company name, your domain name, and your location, and a public key as well. Once you created your CSR, you can send the CSR to a CA, or a certificate authority. The first thing that the CA is going to want is for you to prove ownership of your domain. This might sound like a very simple step, but imagine a situation when you have many backend servers and many domains. You might actually not even have access to the email that you need in order to prove your ownership. Once you've overcome this hurdle that seems small, the CA can issue your signed certificate and you can obtain it from the server. Yay, you got your ticket. Once you have it in your hand, the next step you want to do is update your server key store to use the retrieved signed certificate. Then you're going to go from the situation when you have this annoying "your connection is not private" message to everything's okay, everything is signed. But you have to repeat this process with every signed certificate you want to issue and whenever your signed certificate expires. So obviously, what are the disadvantages of this approach? It's time consuming and it has many complex tasks and steps. And because of that, it's human error prone. And you have to remember those spreadsheets. You have to remember to renew every one of your certificate before it expires. And if you have a system that has a lot of microservices, it's an additional overhead because you have to deploy your certificates to every one of your microservices, and it's a big overhead. So here comes our first tool to the rescue. It's called Acme Protocol, and it provides a simplified way to process and obtaining your certificates. What does the Acme actually stand for? It's Automated Certificate Management Environment, and it's primarily used to obtain domain-validated certificates. The whole idea behind it, as I said, is to minimize human intervention. It's been developed and used by Let's Encrypt, which is an open source, and it's been a standard since 2019. I'm going to pass it to Wokjong, that's going to show you some examples of Acme Protocol and how to use it, and Let's Encrypt.
Thank you, Hel. So there are two key parts of Acme Protocol. One is server and the other client. So Acme Server is a certificate authority which is capable of issuing signed certificate automatically. So Let's Encrypt, Bypass, and Zero SSL, those are the famous providers of Acme Server. And Acme Client typically runs on a web server, and it proves to Acme Server that this domain on the web server, this web server is really having a control over the domain, which it needs to get the signed certificate for. So we'll have a look at the flow of Acme Protocol comparing with the previous traditional certificate management model. So if you remember, it was the server admin who is initiating the certificate request and who is responsible for renewing the certificate upon its expire. In this case, with Acme Protocol, it will be the Acme client who is initiating the certificate request by sending out the process with a key pair, So that request will contain the account creation request and an optional email address that will be used for later for the issued signed certificate for its expiry or renewal. And it will contain the domain information and public key signed by private key. So once it is sent, the Acme server will be able to identify the Acme client. And Acme server will send out the challenge to the client so that it can verify the ownership of the domain. So it would ask provision a specific contents in a specific location of the web server. So it will be something like domain www.acmedemo.cf/well-known/acme-challenge/nonce. Or it would ask for provisioning the DNS record with the specific contents. So once those contents are provisioned by the Acme client, then Acme server will fetch the contents in order to verify the ownership of the domain. And once that is done, Acme server finally able to issuing the signed certificate for the domain. And most of all, the good thing over here is, if you remember in the previous example with the traditional model, it was the server admin needs to repeat this process again and again for the certificate that is expiring. But in this case, once this chain has built, then it doesn't need to be repeated again and again. And also, in addition, you can see many of the steps has got dropped out. So it became much simplified. So we're going to have a look at the demo with using the Let's Encrypt that I mentioned briefly in the previous slide. So they are most well-known Acme server implementation since they invented the Acme protocol. And they are also providing the Acme client, which is Certbot, the certificate management agent that can be run on many types of web server on the operating system, you name it. So I'm going to use those two for my demo. So let's have a look at the demo. And I'll present you first with the full automated case scenario first. So for this demo, I'm running the simple Nginx web server running on my domain, which is acmedemo.cf. And as you can see, it doesn't have the secured connection yet since I haven't got the SSL certificate yet. So on the web server, I'm going to install the Certbot agent, the Acme client first. And I'm going to execute the Certbot automated executing command. So once I execute the Certbot command, it will be asked your email address that will be used for account creation. And you can get the information of the signed certificate issued later on for its renewal process or revoke. And yep, you're going to accept its terms of service agreement. And then most importantly, you need to give the domain to this client. And once the domain is given, then it will going to communicate with Acme client. Between Acme client and the server, they will exchange the challenges and the verification automatically. So I'll wait for the command executed. And in a few minutes, you will see the certificate has been received and the keys are stored in your web server, and the certificate has successfully deployed. And once this is done, I'll go back to my web browser and I'll refresh the page. And voila, you can see now the connection is secured and the certificate was provided by Let's Encrypt. So this was a full automated scenario. So for your information, I'll give you another look at the manual configuration case in detail. The first case will be the HTTP challenge. So in order to have the HTTP challenge, you need to update your web server, your configuration, and specifying the location where you want to have the provisioned data for. And then you're running the certbot command with preferred challenge type as HTTP. And it will give you the instructions of giving you the domain. And once the domain is given, then you will be asked to create a file with the contents on a specific location on the web server. So I'm going to create the file with the contents for the domain verification. So that provision data will be fetched by Acme server, and that will be used for its verification. So I'll give you, I'm going to have the same process for my another domain given, www.acmedemo.cf as well. So in this case, I gave the option of dry run since I already create the SSL certificate for my domain in my previous example. So you are not going to see the actual certificate is redeployed, but if would have been asked if you want to revoke the certificate or renew the certificate without the dry run option. So here is the result of the run. And also, I'll give you some detail for DNS challenge as well. So the scenario will be the similar, and the commands will be the similar, except for the preferred challenge option to DNS. Samely, once you give those domains, and you will be asked to provision the data on the DNS record. So as you can see, once I give the domain, and it will be asked to create a DNS record with the contents. So I edit the record set and record type as a text and create it. And that will be do the same thing. And also those record will be fetched by Acme server. And once that is verified, then Acme server will be able to issue the signed certificate for the domain. Okay. So as you can see, there are lots of benefits out of using the Acme. So as you saw on the demo video, there are lots of steps that has been done by server admin traditionally, and those steps are now gone. Also, it is providing the automation process of issuing the trust certificate, and it will keep track of the certificate expiration, and it will give you the option for renewal or revoking the certificate when it is required. And most of all, it is offering you the best of breed TLS and certificate PKI best security best practices. And it is supported by the open source community, which means that it will be evolving on, and it will have the enhancement. And it will also give you the low cost of certificate management cycle in terms of the human effort and the time-wise as well. And cherry on top, this is free if you are using with the Let's Encrypt Acme server. So now Najam will come and give a talk for the cert manager.
Yeah, thank you. So thank you, Wook-jong, and he covered, how we could sort of use tools to, automate the process. Now we take it to the next level, right? So how do you scale it? Right? With certbot, you have to integrate it with, each of your microservices. What if you have tens, hundreds of microservices? How do you scale it? And there comes Cert Manager. Cert Manager, it's a Kubernetes add-on, which facilitates the automation of the certificate issuance and the renewal. Right? So it uses the Acme protocol and integrates with wide variety of DNS providers. And that's what we saw. There are two parts. Usually with Cert Manager, it's easier to do it with integration with a DNS provider. So with Cert Manager, there are a few things that it handles, right? One is the integration with Kubernetes, right? So over there are basically in Kubernetes, there are three parts to it. First part is having a webhook that Kubernetes will call back into Cert Manager when a resource that has to be handled by Cert Manager is created, right? A certificate resource is created. So the advantage of that is in your deployment, you're just defining a manifest. And then Kubernetes is going to invoke that webhook and handle it to the cert manager to take it from there. So the other part is actually integrating with the certificate providers and the DNS providers, right? And the third is once the certificate is available, is to make that certificate available to the the containers that are running via secrets. So next we're going to have a look at a demo. Okay, so is it playing? Okay. Yeah. So in a cluster, as I was saying first, let's look at a deployment, right? So we've deployed Cert Manager. We can see the three components that I talked about, right? So there's the Cert Manager itself that will integrate with the CA provider, certificate provider, and the DNS provider, and then we have the webhook and the injector that will get the cert and inject into a secret, right? That's just to see that the pods are running. So first thing we're going to look at is an issuer, right? So you could have an configure an issuer or a cluster issuer. The difference is an issuer is of a specific namespace. Cluster issuer is across the Kubernetes cluster. So an issuer is basically, and we'll look at an example of issuer. So an issuer, what you can configure in an issuer, I wonder if you could read this, too small. Yeah. So what you configure is, one is what type of Acme server you are integrating it with, the CA provider that you are integrating it. And then the other is the setup for your DNS integration. Here we are using an Akamai DNS for this demo, right? So these are the two things that are provided, and you have your tokens and stuff to authenticate with the Akamai DNS. So this, and once you do this, then you have the name of the cluster issuer, which could be used by the applications. So then the second part is for each of your microservices containers, then you can define a certificate resource, right? And if you can see if it's visible, the cert manager, the API is certmanager.io, right? So here we define the DNS, the FQDN that you want, the domain that you want the cert for, the duration, so 90 days, that's the max for Let's Encrypt. How much before do you want to renew? This was for 15 days before it will renew. The issuer that you want to reference for this certificate. And then finally, the most important thing is once the certificate is there, where do you want Let's Encrypt to save it? And then we are specifying a secret name where Let's Encrypt will save it. And one thing which was not obvious is now the certificate resource you are defining in a specific namespace. A cluster was in a separate namespace where the other users should not have access to. So just for this example, you see that the secret is not there, and then I'm going to create the Kubernetes certificate resource. K over here is just an alias to make it easy, right? Once I run that, the request will go to Cert Manager, and the certs are issued. So we see over here that the LASCON demo, the secret has been created, right? And we're going to look at the content, quickly with a command to see that it was, issued by Let's Encrypt, to see that the validity periods, the domain it was issued to. In a bit here. This is just a command to parse the secret and use OpenSSL to inspect simple text. Okay, here again, if you look top, we see that this has been issued by Let's Encrypt. We see the validity dates, the public key. A little bit down, we see, it was a multi-domain certificate, so you can see the SANs. You could also specify a wildcard certificate in here. Let's Encrypt supports that too, or you can have all your different subject alternate names that you want to use, right? So once you have this certificate, now the next part is basically what do you do? How do you integrate it with your application, right? So in this case, this was just to demonstrate getting the certificate. I was using another certificate request, which was the other one, US Lab TLS, that we use to integrate with GKE Ingress, right? And that is very easy. So the way, and also just quickly to show the details of this, this request to demonstrate that by default, cert manager will create a TLS type secret. Just the certificates are in PEM format, the cert and the key file. But you can also let Let's Encrypt know to create a Java key store or a P12 file. So based on what your application needs are, you can specify that, right? So here again, you can see that we've specified that to create a Java key store with, and also use a specific secret for protecting the key store with the password, and same for the P12, right? So using a secret that we specify to use as a password to protect the P12 file, right? And what we specify is the secret name where cert manager is going to store the certificate. It's just to, again, to look at the certificate. It was a wildcard cert that we wanted to issue. Okay. Now, how do we configure it with the application? It's quite simple, right? Your application needs to support a TLS secret type. Over here, you see at the bottom, just highlight it. Just give the secret name, and the secret name is the same name that we referenced earlier, right? And this could be in the same, manifest. Now we go. This is just to go at a site that was, exposed through that ingress and see that it's a wildcard cert that has been issued by Let's Encrypt. And also, you could go have a look at the cert manager documentation. It's quite good, a lot of examples, and lists all the DNS that it supports integration with. So now what we've seen, right, now if you have, if you have a Kubernetes cluster, you have hundreds of applications, you want to configure certs for all of those applications. What you need to do is just define a certificate resource for their deployment, however you have help chart or however you're deploying it, right? You can integrate with multiple DNS providers, right? So you can create separate issuers for whatever, right? Every company you will see we use, even in the same product, we're using like Akamai and Route 53 and EasyDNS, because operation at different times, it's just, wherever whichever DNS we are using. So with this, you can have multiple issuers created, integrating with different DNS providers. And then there it is, just set it up. And as long as it's running, the certs, obviously, the automation is not only about the issuance of the cert, more importantly, is going to renew the cert for you, right? And the third thing is with Ingress, it supports hot update of the secret. So once the secret is updated, is mounted into the containers, it will reload it. If your application supports that, it'll reload it. If not, then you'll have to do a rolling restart to basically refresh that certificate. So you'll have to take care of that. Finally, looking at some issues and limitations. One which is not listed over here is Cert Manager is a Kubernetes add-on. So if you're not using Kubernetes, then you should use Kubernetes. Or you can have other options using certbot or other forms of integration. So that is one limitation. The other is, you saw, I mean, it's putting it's creating a TLS secret, right? That means that this private key is also there. So how do you protect that private key, right? Anybody who has access now to that secret can get access to the private key, and then it's an issue that you need to see how you protect that. And the most importantly, it doesn't mean that you're done with it, that's it, forget, and the certificate. No, you have to monitor that Cert Manager is running right on your cluster. If Cert Manager fails for any reason, it's just another software which is running. If it fails, your certificates are not going to get renewed, right? You need to keep, you need to have monitoring in place. It supports integration with different, providers, Datadog, whatnots, where you can get alerts and stuff. So to make sure that Cert Manager is running, and also to make sure that it is renewing the certificate. We ran into some issue, still evolving, getting better, but I mean, it wasn't renewing the certificate. There was a bug, so you need to keep upgrading, and so the idea is you still need to, but the amount of work that you have to do now is a lot less, right? Compared to, and also it's scalable, right? You can go have thousands of certificates. However, if you're using Let's Encrypt, there's another limitation that is there, is the number of certificates that it will issue, it will allow you to get per registered domain. I think the limit is 50. Now 50 seems like a big number, but it's per registered domain. So if you have a lot of subdomains, they all count in the same, right? And unfortunately, if you have your production and your test and your staging under the same registered domain, then your 50 per week are going to run out pretty quickly. So this is something you need to keep in mind. And that is pretty much it. Questions?
So the Cert Manager, it runs from the same machine it's issuing the certificate to, or the same container is issuing the certificate to?
No, Cert Manager is running, so it's running in Kubernetes, right? So as at the beginning I showed you the pods that were running. So it's running its own containers. Cert Manager doesn't, talk directly with your containers, right? Cert Manager, there are containers that are running. Kubernetes invokes that. And Cert Manager will get the certificate and put it in Kubernetes secrets. And that's from there your application will use it.
Right. So if I have machines that doesn't have internet access, it doesn't matter because Cert Manager is in a different container and that.
No. You need your cert. It needs internet access. It needs access to your certificate provider, right? Let's Encrypt in this case. So if it can't get to Let's Encrypt or the DNS provider, then it cannot renew the certificate.
Right. It's wherever the container that Cert Manager is running, it needs to have internet access, but issuing to another machine.
Yes. So if you have network policies in place in Kubernetes, limiting access in your namespaces or for your application, that would work. Yes, Cert Manager, whatever namespace is running, it needs access to the internet from there. So other questions?
Well, thank you.
Right. Thank you. Thank you for joining.